So, welcome to those discovering Walking Tree for the very first time. Uh, Walking Tree stands as a vanguard of technology-driven innovation, specializing in the design and deployment of cutting-edge cross-platform web and mobile applications. We are not just a company, but a coalition of visionaries and pioneers passionately dedicated to facilitating seamless system integrations and accelerating momentum of digital transformation initiatives. Our core expertise lies in advanced data integration, analytics, and the transition of legacy systems to contemporary high-performance platforms. Armed with a comprehensive suite of business intelligence solutions spanning across various domains, we are uniquely positioned to empower businesses. Our bespoke solutions cater to the intricate data-centric needs of our clients, offering them the agility and the efficiency they require in today's competitive business landscape. At Walking Tree, we strive to be not just service providers, but trusted partners in your digital journey, offering industry-leading expertise and technological innovation to reshape your business for the future. I see quite a few familiar faces, so very warm welcome back to all of you from the previous sessions on generative AI. Your continued presence underscores the value you derive from these sessions, and we couldn't be more pleased. Today, we speak on the best strategies to navigate LLM landscape for building intelligent apps. LLMs have emerged as a force majeure in the world of knowledge generation and reasoning, increasingly viewed as a transformative tool for developers aspiring to create hitherto unachievable applications. However, a sole reliance on LLMs may not suffice in the quest for truly impactful apps. The true potential of these technologies unfurls when they are judiciously integrated, and our distinguished speakers will illuminate on this topic further. We have reserved some time towards the end for your questions, so I encourage you to drop them in the Q&A box throughout the webinar. So let's all harness our collective intelligent presence today for a richer and more informed discussion. We look forward to your active participation. I will now introduce our speakers of the day. We have Scott, who has over 30 years of experience and has been an astute problem solver, entrepreneur, and technology leader driving our organization towards a diverse range of digital and data analytics capabilities and a culture of client-centric innovation. In addition to his invaluable guidance and insight, Scott actively shares his knowledge with our clients and the Walking Tree team, empowering them to confidently navigate challenges, leverage opportunities, and fuel innovative growth. We have Abhilasha, whose illustrious career spans over 2 decades, during which she has led high-performing teams in the development of enterprise-scale products and applications. Her expertise includes over a decade of experience in driving the end-to-end design and development of complex analytic solutions for diverse industry segments. Abhilasha's unwavering commitment to excellence, coupled with her deep understanding of technology landscape, has earned her a reputation as a seasoned leader in the field. We also have with us Shubham Bharadwaj with a robust background in data engineering, artificial intelligence, machine learning, NLPs, and Kubernetes. Shubham is a seasoned senior software engineer with over 4 years of industry experience now. He has a proven track record of designing Flutter GPT-3 based applications, building applications that leverage machine learning services on AWS to process videos, images, audio, and text, creating a cutting edge MLOps platform that addresses the limitations of existing platforms. Now, before we get on to today's agenda, I just quick reminder, we will be answering all your questions towards the end of the session, so please leave them in the Q&A box. I'll just hand over the session to our speakers, so just please bear with me once. Thankfully, I can see a few more people joining in. So right here we are. Hello, Scott. Good evening.
Hey, Prince Yu, how are you doing?
I'm good. How about you?
Hey, doing great. Thank you. Very good. Well, thank you for the introduction. And Prince Yu, what I'll do, if you want to share, that's fine too. So today, what I'll do is I'll kind of set the stage for us a bit, and talk about the different the different options you have, and then how to select a bit, and then from there we'll go into really some more detail, and then end up with maybe a demo of some of these models. So if you'll go to the agenda slide, French youth, that would be great. All right, thank you. So like I said, we'll talk first about the open and closed source LLMs, and I won't spend a ton of time because I think we want to get to more of the integrating those LLMs, and then the apps designing using the different LLMs. But we'll talk a little bit about open closed source, and then selecting really the model that best suits your needs. And then I'll turn it over to Abhilasha after that to talk about integrating LLMs and applications. And then Shubham will talk in regards to apps designed using different LLMs. So that's kind of the structure and the agenda of the call. So with that, we'll talk about open and closed source LLMs. And there's several big players in this space. Some of them you're probably very well familiar with, in the Metas and the Microsofts, NVIDIAs, and of course, OpenAI. And then, we have others as well, like Cohere, and Anthropic, and of course, Google in that space as well. So we'll talk through some of those, look at some of maybe the advantages and challenges for each of those. So first, let's look at the closed source, or the proprietary options, right? And we will share this deck, by the way, but just to give you an idea of a few of these, and really kind of how we go about looking at them from a walking tree standpoint anyway. And really that's based on, how many parameters were they trained with? What's the context, the training, what's the quality, the speed, and fine tunability. So all those things will come into play when you are selecting a model to use for your application, right? So just because one is maybe really good at quality, maybe the speed is not so good. So there's some trade-offs you can do, and maybe even need to have some fine tuning in there as well. So, but of course, the latest one from OpenAI is GPT-4. Really good quality at the moment. The speed maybe is not as good as some of the others, but certainly if you're looking for quality, that's definitely the top one as far as that goes. Of course, GPT 3.5 Turbo, which is what many of us have been using for a while now. That's still very good quality, and then with maybe a little slower speed. But if you're looking at something with really decent speed, decent quality, then you've got Claude. And then on down the line, really, there's others, like Babbage and Curie and so forth, as well as Command Medium as well. So some of those are really fast and have good fine tunability. So again, you really want to look at each of these and just see what's most important. So what we try to do here is kind of gauge that and give you a little gauge on what's most important to you, right? So that way it'll help you kind of go through and look at what might be best. So, but that's from a closed source options. Okay. And then let's start looking at the open source options, right? And, with any open source that you use, right, whether it's in this space or libraries or just in general, software in general, right? So what are the variations? There's permissive licenses like Apache 2.0 that, more or less, allow you to do what you want to do with a model. And then there's a restricted license, and there's restrictions that come with that, right, on a commercial use for the software, but they don't prohibit it necessarily, right? So And that one, we say, draw your own conclusions, whether this works for you or not. And that's not a negative. It's just, hey, you have to decide if that's important to you or not, depending on the application that you're developing. And then, of course, there's the non-commercial licenses like Facebook's proprietary ones, or maybe a Creative Commons that it really explicitly prohibit commercial use. And those are not really a good choice, right, for building apps on. Okay. And then just from just like we did with a closed source or proprietary options, you can kind of see from an open source standpoint, what's available to you, like Google AI and, Electra and Stability AI and Meta and so on. If you look again, you got to look at what's important to you. Licensing wise, is having just a pure open 2.0 Apache 2.0 option available to you the most important thing, or maybe maybe you can deal with having a more restricted license, right? So again, this chart, I'm not going to talk through every single one of these, but again, just to give you an idea, when you're looking at these, you kind of know and you can kind of weigh through your options on what might work best for you. Okay. Well, what about selecting the model that suits you best? So with that, what are the things to really think about when you go into selecting the right model? And if we look at this from the options, you got off-the-shelf models like OpenAI, Cohere, and then you've got customizable, and then you could train your own. Well, let's look at off-the-shelf models like OpenAI first. So in that options, basically what do? You subscribe to use it, utilization of existing off-the-shelf tools. You can really, harness the power of a pre-existing LLM, right? So it's there, it already has had training and it's there and it's ready to use. So it's easy, and advantage-wise, it's easy to get started. And again, it's an existing model that you can use for a generic use, a use case, right? Maybe it's a good use case for like text to SQL and have knowledge behind that, right? Maybe you need to do, it's a good option if maybe you need to do prompt engineering, right? Using 0, 1, or 2, one or few, short learnings. So what are the disadvantages of that? No domain knowledge. So the model's out there, it's developed, it's got a lot of information, but it may not, probably won't know about your specific domain, right? So, and again, with that too, you're tied to a provider, and it could result in hallucinations, right? So you may get something back that's like, wow, that's not really even in the ballpark. Well, if not an open shelf model, then let's look at the customizable ones, right? So what are some of the options there? Well, one is you can consume them with using guardrails, right? So you can, by guardrails, those could be whether it's putting guardrails around the topics, or maybe it's a safety issue. You're trying to protect against certain words and phrases and those kind of things being used, or maybe it's a security issue. So, but you can implement guardrails with those. So that's one form of customization, is using guardrails. Well, what's the advantage of that? It can help, reduce hallucinations and bring structure right to your model. Disadvantages with that is you're tied to a provider with that. So if you're using guardrails, whatever company you're using that with, you're tied to a provider, right? So the next form of customization might be that you augment, right? So maybe you've got a database that you leverage to do lookups to customize the LLM really according to your requirements, right? Or what's specific to your organization. And that is really the advantage, right? Is that you augment the LLM with domain knowledge. And again, the disadvantage of that is you're tied to a certain provider. And then what's the other customizable option? Maybe fine tune, right? So fine tuning is where the user fine tunes or tailors the LLMs to the org's needs, and that's nice. And the advantage of that is that you can influence the behavior of the model by means of that fine tuning with a specific data set, right? Really, the disadvantage to that is it's just additional cost and tuning and usage, right? But again, it's weighing out those things. Maybe that's important. Maybe the cost is okay. It's something that you can absorb because you're getting good value out of that. So, and then lastly, training your own model, right? So build and train your own model from scratch with your data. That gives you absolute complete control on data and models. The disadvantage to that, of course, is it's complicated, it's time consuming, and it can be really, really expensive. Okay. Well, what about choosing your model based, what are our recommendations, right? So when you choose a model, kind of, what are some of the things that we might recommend to you? Well, most projects can start with like GPT-4, and that's just a real good place to start with a proof of concept or the feasibility of the task you're trying to perform. Well, if cost is a factor there, consider downsizing, right? GPT-3 and Claude are really good choices, and they have comparable performance. And I would say that if your aim is increased speed and cost efficiency, really, any of these providers will suffice for you, though, although the Anthropic option really stands out. It's really a good option, and really the most contemporary choice. If you need fine tuning, consider Cohere. If you need an open source OSS, if you use that, if you really need it, right? But you can see back in that chart some of the advantages and disadvantages of using that, using an open source. But again, everything needs to be weighed out, right? And maybe there's a times and ways that you can mix and match and use them for use a combination even. Okay, next. Okay, and with that, just a brief summary of the different types of open source. Those are the main ones that the ones we've highlighted are really the major ones that are being used. And then, again, just some very general guidelines when you start to develop your models and when you're selecting what model you're going to use. So with that, I'm going to actually turn this over to Abhilasha, and Abhilasha can get us started on talking about the app development with LLMs.
Thank you, Scott. So there are a variety of models available, both proprietary and open source. So how best can we utilize them when we are actually using the power of LLMs in our applications? So in order to be able to rightly put to production, like productionize an LLM and be able to use it to the full potential, that is where the real challenge lies. Because just using LLMs, like we all have been using ChatGPT, and we know that it is it's easy to just communicate to the bot available. But then how to apply that to your use case, to your enterprise? And that is where we will be looking at different aspects from that perspective. So starting with, if we have to look at the complete application development flow. So first of all, we would start with the enterprise data. So if you see here, because you have the LLM, but you want to augment the data of the LLM so that it is able to cater to your enterprise needs. And that is where the enterprise data becomes important. That is the raw data which gets used. So again, the data can be in different formats. It can be at different places. So we parse the data, and in most cases, since the volume of data would be huge, so we would decide to use a vector database, which is like a most convenient and efficient way to be able to store and then search over the data. Also, so these embeddings of the data in whichever format it is would be stored in the vector database and be available for the models to use. Now, once we start setting up our pipeline, so if we think of this as a flow where the user starts asking a question, how does that get resolved or responded by the complete application which comprises of the LLM, and then so it starts with two main aspects: the prompt chain and the tools chain. The prompt chain, is the most important part of your how you're using your LLMs. If you have experience with ChatGPT, how well you can write the prompts, your model will respond to you. So that is where, when you're actually applying this to an application, you have to take care of an aspect of standardization and a templating. So that is where we have a prompt template, which gives you a structure of how you want your prompt to be, and maybe some static text, which will be part of your main prompt. Then you would want to augment the prompt with the extra data. So this data could come from your vector database. It could come from the web, if you are using some like plugins or web retriever. So accordingly, the data will get augmented, and then the final prompt will be formulated. And this may additionally, so depending on, so it's not like you would be using all the parts of it, but in a full-fledged enterprise application, these aspects become necessary, because when you're trying to use LLM, you should do in the most, you can say, most structured and standardized way. And that is where, since this field is evolving, of course, there are new standards coming in, but then this base standard, and there are some frameworks which have like made this easy for us as we try to develop applications using LLM. So frameworks like LangChain and Haystack, which help you integrate the model and also help to cater to these different aspects. So whether it is a prompt chain, a tool chain, so tools come into picture when you want to do something extra, when you want to say, so one example could be get data from, say, a web retriever. So that could be a search tool which gets added. So similarly, depending on the need of your enterprise application, you can have tools, and there is a list of tools available for LangChain and Haystack. Then there can be an information search module. So this would be the part where your framework will connect to the vector database and pass on your query to give the relevant response. And further, you can have a memory buffer component. So this is required in order to keep the context of the conversation. So for example, in LangChain, we have a concept of conversational memory, wherein you like keep a track of the conversation, so that as the user is communicating with the application or the bot or the so it keeps track of the say a set of previous conversations which have happened, so that the next conversation would be in flow of that. And again, that could be structured in a way which suits as per the requirement. So if it is a freshly new unrelated question, you may not add it to the buffer, but only if you need to keep track of the conversation, you may add it to the buffer. So that is up to the developer how you use these tools to make the best use of your LLM. So finally, making use of all these this pipeline of the different nodes, you can actually formulate your response and send it back to your user using the LLM. So this is fed into the LLM from where the response is generated. So again, the different tools here, again, it could be like the different document stores. So the different, say, any additional agents or tools which can be incorporated. So making use of all this, you can build a application. And then, so if we talk about the two frameworks, and there are other frameworks also, but I have picked these two frameworks as LangChain is much more popular when you talk about OpenAI models, and Haystack is another tool which has been like used with the older models also. So now it has added OpenAI, but it uses the other models also. And also it has some features which actually are not available in LangChain. So, and they have their own advantage. That's the reason I have picked up both of these. And if you look at each aspect of taking a model into production. So starting with the LLM support. So whether the two framework is allowing you to connect to the LLM, and this is anyways like all the popular models, OpenAI, Cohere, all are provided by these two, and so it can be connected and used. Then coming to prompt template and engineering. So again, a very important aspect in using LLMs, because prompt engineering is what like finally gives you the expected result, and that's how you can because unless if you really have a requirement to fine tune, prompts are the real power in your hand, using which you can get your job done. So, and like there are multiple concepts which have come in on how well you can use your prompts. So be it like a chain of thought prompting, where you like ask the model to break this task into multi-steps and then do it in the fashion of reasoning and applying the answer. So, and then there is a React methodology where you are forcing the LLM to do some reasoning and then acting. So there are different white papers on this, and these frameworks have actually provided you templates for in line with these concepts. So be it React, chain of thought, then there is action plan generation. So where the model tells you like these are the things it will do to give you the response. So that actually improves the performance of your model. If just imagine like giving the answer in just one go versus being able to reason and like think back and check back in your knowledge base and then give the answer. So just like how we humans work. So we are forcing the model to do the similar thing. Then coming to process orchestration. So again, like once you have your model, your prompts ready, your model is giving the results, you would want a proper workflow to be set up in how the different components of your pipeline are interacting. And it is possible that in your complete application workflow, there may be a need to invoke multiple LLMs, because sometimes we would want to say go for a cheaper LLM or a own version model for a simpler activity, for which we need not go to ChatGPT. So accordingly, we can actually orchestrate and have a chaining of different nodes or components which will perform different actions. So there could be one node connecting to OpenAI to do, say, some question answering, but there could be a separate node to just do the embeddings from maybe a lower level model. So the chains or the chains in LangChain and Haystack has a concept of pipelines which try to achieve the same, the process orchestration. And then once you have your process, of course, very important thing is how you're getting your knowledge. So you have to connect to, say, some data sources and get your data. And maybe if your data is already in vector database, maybe you directly connect to it. But then if your data is in some documents, so you would want to bring it to a structure where you can easily query upon it. So that is where you will fetch your data from these different document loaders. Then you will do the processing, maybe text splitting, then converting to embeddings, then finally loading into your document stores. So that is also provided by both of these frameworks, and it connects to most of the popular vector databases to give you the capability of question answering. Then the next thing, of course, question answering. So there is a different flavor to how these two interact and give the response. So with LangChain, you have like it queries the data and then it passes on to the next, you can say the next node of the pipeline or the chain to create the response. And similarly in Haystack, you have a concept of reader, where it is just reading the question, reading the answer from the document, or it is a retriever. So the difference would be like retriever would actually retrieve the section of the document which is related. So something like a similarity search, and then you pass on the retriever to the next node of your pipeline, which would be a generator. So generator would generate the response. So accordingly, like these are different ways of how you interact with your knowledge source and extract the data. Then if we look at deployment, so again here we can say that so Haystack has an edge here because it provides a REST API for many of the actions. So actually you can deploy your model and then you can also test it, you can evaluate. So you have different APIs to provide them. Then coming to agents and memories, so agents are a special type of, you can say, modules which are enabled by complex prompts and give you a certain type of behavior, and you can attach tools on top of it. So you have a concept of agents in both LangChain and Haystack, and maybe I'll show you some of the examples where how they interact and how they reason and give the answer. Also, GPU integration can be provided in both these frameworks. There are other features like they have these utility packages which enable you to format the result or make some additional, say, queries to web searches and all. And then they have a module for evaluation also, which which gives a structure of how you would evaluate your model performance, and so that you're able to measure and decide if there's a need for improvement, and also be able to monitor in the long run. And finally, use case wise also, so both LangChain and Haystack cater to all the common use cases which an LLM provides. Additionally, one thing which I saw in Haystack is a capability of annotation. So it has an annotation portal where you can actually name your data set, label your data set in order to provide that as a evaluation data or as a test data for your model. So that is one feature which Haystack provides. So if we look at all these aspects, so these are all the different levels of how you're actually building an application using LLM, and with by means of using these frameworks, you can actually bring a structure to your application. And because these are all mature tools which have already done some work for you in a way that you can utilize the base and achieve good results. So it is always recommended to pick a framework and use it in your application. Now, when you're using LLMs, we need to remember that it will not work immediately in the first case, and there will be issues. So there are issues related to latency. So models like ChatGPT and GPT-4, they are slow, as Scott mentioned. So as we are using it, we need to have a methodology of how best we can use it, because they also provide ways of how you can say cater to the errors. Sometimes you get the rate limit error, or say the OpenAI error. So depending on, you can actually have a retry mechanism to handle these errors and have a multiple retries before you actually fail the application. Because in a standard application, you would want a mature behavior, and that is what OpenAI provides you to handle it in a smoother way and cleanly. Also, other things like hallucination, or if questions are not being properly answered, if it's just saying that, so a dodge question is like, it just says that I'm a model and I don't have the knowledge to answer the question. Or if there are any changes to the prompt, any toxicity or profanity, any long-winded answers which are not as per expectation. So how you can bring in control to these aspects? Again, whatever you do, you can make use of these frameworks as a bottom line. And maybe I would repeat that just to make the importance of the frameworks in all this. So if we look at how we can avoid and make, avoid the errors, avoid the problems with the LLM, and try to make the best use of it. So using prompt engineering in the right way is one very important aspect, because in the prompt, you can actually provide a structured instruction to the model on how it should perform, what it should not do, provide a context if there is a historical association with that knowledge chain, or if there is a knowledge base data which you want to attach, so that becomes your context. and then you attach your question. So instead of giving a plain question without any context, where you leave it to the model to behave in its own way, and that would lead to hallucination, you can actually control it by giving the structure to your prompt. So that is why prompt engineering becomes very important. Also, since you are looking at using the LLM in your enterprise, you would look at how you can adapt to your domain, and that is where, and how you could augment the knowledge, and that is where the concept of like these vector databases which you would use to augment the knowledge, and then you would have to take care of feedback monitoring and continuous improvement of your prompts and the how well your model is behaving. And finally, you can also, for issues like toxicity and profanity, you can avoid those by applying guardrails, which is like a Python package which allows you to provide a you can say a reliable AI markup language, a rail format, where you can actually give specific validations you want to perform on the output before it is given back to the user. And also, maybe if you're not satisfied, you can make a another call to the model and not send the response in the first time, so that control can be added. So with all these things, you can actually control your model behavior and avoid hallucinations. And you have to have an evaluation methodology, because you will start small. You will start maybe just by experimenting your prompts in ChatGPT. Then you will have a proper model structured prompt defined. Then you will build your application around it. You will add more data to test it, and you will have to ensure that you're able to cover all aspects of the testing in order to actually be able to say that your model is working well in all. And since it's a language model, you are actually, of course, if your use case is a very limited one, but usually you would want a human-like conversation. So there, the plethora of variations is actually limitless. So that is where you have to really keep evaluating and keep validating your model. And you can have some evaluation metrics like have a predetermined expected responses, and have a matching against it to see how similar they are against the expected ones. Or you can ask the LLM itself to rate if this answer is good enough. Or you can have say some old answer which you want to compare and see if your new answer is comparable to the answer which was expected. And then you can have other static metrics, like you can again use the LLM to give a rating to your answer. So things like that. And this is something where you will have to say be a little you can say innovative and apply it to your use case based on the needs of the behavior. But as you are actually using it, you have to remember that you are in a continuous cycle of development, testing and deployment, and then taking a feedback, again testing, and again deploying. So this cycle keeps continuing because there will be variations and there will be things. So have a mechanism of feedback so that you are able to incorporate the test data and improve your prompts to give a better performance. Also, there will be scenarios where you would want a fine tuning. So you would identify those scenarios and follow the fine tuning. And the same cycle would work when you're doing it as a developer. Then you do it as your proper team testing. You give it for UAT. So every cycle where you test, and finally when you give it to the end user. So you have to keep repeating and ensuring that you're collecting feedback so that your model is improving and never stagnating. So with this, I would quickly show you a few examples of LangChain. So basically, I just wanted to give you a view of how using these frameworks you can bring and you can quickly develop your code and reuse the structured nodes which these frameworks provide in order to bring a good overall behavior of your application. So if you look at this haystack, this is a haystack pipeline using Pinecone. So you would set your environment and you have a document store which you would import from your Haystack. You would set your parameters. Then again, Haystack provides you a logging capability where you can actually set the logging level, whether it is debug or info. And then you would, so you have different utils of how you want to collect, say, fetch your articles from HTTP, or you have to combine documents. So you can make use of these utils. Then you have the nodes. So again, prompt node is a very important node which allows you to like consolidate the capability and behavior and attach a prompt of your choice, and then connect to your LLM and be able to respond to your required behavior. So, and then prompt is, node is one part of it. And then putting these node together, you would form a pipeline. So again, here there are two types of pipelines. So it could be a document search pipeline. So of course, there are many other pipelines. And the idea is like these pipelines are already like set up with some nodes which have a predefined behavior. So if you have a similar behavior, you can actually get up and running by just importing these pipelines and maybe making certain modifications as per your need. So for this example, like we picked up some policy documents and we converted into, say, a document store, then created a retriever. So like retriever is a component or a node. So this is an embedding retriever, which actually would store the embeddings for the given document store. So here we are using the ADA. So this gets stored in your document store, which is the Pinecone in this case. So accordingly, you can use different, and then you can apply the pipeline. So here I have used two pipelines. So this is the document search pipeline, which would only search the document and give you the response. So if that is the requirement, you can use this. So you can see that you pass the query and the retriever is able to respond. So, and then if you're using this generative QA pipeline, so it's like a question answering pipeline, which will take a retriever and a generator. So retriever will actually retrieve the data from the document store and pass it to the generator, and then generator will generate the response. So accordingly, like this is one example, and maybe I'll just, so if you see here, so the first one, which is the document search pipeline. So it gives the document basically from where it got the data. So tell me something about the working hours policy, and it is able to fetch the content and the name of the document. And suppose if this is the generative question answer pipeline. So here it is actually giving you a proper answer because it has the retriever and the generator. So similarly, if we look at the next example, so this is using LangChain with Deep Lake. So Deep Lake is another kind of vector store. It is actually, it is a combination of data lake and vector store. So gives you more capabilities on your vector store. And again, LangChain with Deep Lake. So this example where I've taken a message text. So message text is like a text with some conversation which the user has with the chatbot. And then we are trying to ask questions on top of that. So if your organization has like a chatbot and there's a lot of data getting collected, if you want to derive value out of it, so this could be a use. So what we have used is a Deep Lake. So again, the syntax will be slightly different, but the idea is similar. So and additionally, in LangChain, we are using a text splitter. So obviously your data may be huge. So you can actually chunk it and then split and then load it into your vector database. And then you can use your, say, embeddings to load it into your data set inside the data lake. And then finally, you set up a retriever. So you're giving like to check the distance metric is cosine similarity and the number of arguments or the top K is 4 here. So accordingly, your QA, your retriever will fetch the data. So here we are using the LangChain retrieval QA chain. And you can give a chain type. So stuff is like it will give all the response. There are other variations here like map reduce if you want to achieve a summarized response. So you can actually try out these different variations depending on your use case and apply the most suitable one. And then you can see like for this query, So yeah, this was the question I entered. So what is the overall sentiment? And it actually tries to analyze and give you a response. So what were the main issues, and the conversation was helpful, and the main issues were the product description or things like that. So it is deriving that from the conversation. So similarly, there are other examples, like this one is using a web retriever. So I will quickly show this one. So this is an agent which is using a web retriever. So basically, if you when you are using an agent, which actually tries to induce a concept of reasoning and acting, which so this prompt template actually uses the few short React. React is that reasoning and acting. And just to show you how this, so in the prompt we have given it like how it should break the problem and try to answer the question instead of directly answering the question, because the question is not a straightforward one. So there is some amount of reasoning which needs to be done, and that is how the model behaves, and it tries to break the problem and gets the answer. So let me show you some example here. So I tried to confuse the model by asking it who was the youngest Indian PM who stayed in power for the longest duration. So actually there are two questions here, youngest and longest duration. Now, so the model was a bit confused. It tried to apply a lot of reasoning. So if you see here, it actually tries to get data from different, this is using a web retriever, so it's getting data from the web. It is trying to apply logic, just like, so the input is this, and then this is the observation. So it is saying like, okay, this was what it thought, and then finally it did, what tool did it use? It used a search, and then finally it learned this. So it will actually show you how it is using the information, and then finally with all this observation and analysis, it gave a response that, so Rajiv Gandhi was the youngest with the longest duration. So this is these are some examples of how you can use the capabilities provided by these integration frameworks. So now I will hand over to Shubham to talk about the different models you can use and see some real use cases.
Thanks, Abhilasha. Hi, everyone. I'll be soon sharing my screen. I hope my screen is visible. Sure, let me get started. So as Abhilasha mentioned, in this section, I will be discussing the apps which have been made using different LLMs. I'll also do a quick demo on the usage of different LLMs. And I'll also delve a bit deeper on the choice on the various parameters that you need to consider while making a choice, particularly with regards to open source LLMs. So to start with, let's talk about the apps which are already out there, which make use of these large language models. And as most of you are anyway aware, the two most prominent apps of our times, which are, or rather three most prominent apps of this time, which are making headwinds, are ChatGPT, are Bard, and they are Bing AI. Now, while they are powered by different models, but it's not the fact that they are just powered by different models which makes them different. So of course, ChatGPT is powered by GPT 3.5 Turbo, and you have the GPT-4 equivalent as well. So in ChatGPT Plus, you can use GPT-4. On the other side, you have BARD, which is powered by Lambda, a language model for dialogue applications. So Lambda is also as optimized, at least meant to be as optimized for conversational applications as Turbo was meant to be. However, if you compare the two applications, they differ in terms of their user experience. BARD is considered to be better in terms of user experience. BARD is considered less good compared to ChatGPT when it comes to summarizing and paragraph writing. So there are areas where BARD is better. For example, BARD has access to live data on internet. Of course, it's by Google, so it does have. However, ChatGPT is trying to catch up on that by introducing plugins. We have Bing AI, which is powered by GPT-4. So Bing AI is a Microsoft search tool, and it is using GPT-4 to give the best possible results of analysis on different questions which come up. So it is more than just a search tool like Google, which was like just indexing the results. It also does that, but then because it has GPT-3 and GPT-4 at the backbone, so the way it produces those results based on your queries is different. On top of that, right, or rather following up to these applications is Claude. So as Scott was mentioning in the beginning, Claude is one of the biggest competitors to OpenAI models. So OpenAI models like GPT-4, they are considered quite nice. Of course, they are quite nice. Their performance is quite good. GPT-4 currently stands as the best model. But then when you go to the niche set of models, for example, when you go to the models currently being made by Anthropic, which is actually by ex-OpenAI engineers and which is backed by Google, you realize that what they are doing is really cool. This Claude is actually the backbone of Claude is quantum computing. They have a quantum computing backed structure. So the infrastructure is driven by that. And Claude is meant to be a model which is expected to ingest huge amount of data. So it can ingest even a book of yours in a few seconds. So its context size is like 75,000 words. And if you really want to build applications which are which process huge amount of data and are also context aware, and they are aware of some ethical context, Claude is considered as one of the best models. So it's, of course, it's not open, so it's not available to everybody right now. So it's very selective, but they are moving slowly and gradually. So on one side, it can process much more data. It is way faster because of its quantum computing backbone. On the other side, it is also ethics aware. It has a constitutional AI. So they use the word phrase constitutional AI when they describe Claude. So it has its own this sense of morals and ethics is embedded. So it is meant to be a helpful assistant, which is meant to prevent those kinds of errors which other models do or have to be explicitly prompted not to do. Now let's come to applications which are kind of custom applications. So what I show here is a Duolingo Max app. So this app is meant to be an education app, and in this app, this app has been existing for quite long. Just that they have added 2 more features to it recently. Explain My Answer is one of them, where whatever answer the app gives, this education app gives, language learning and other kinds of education subjects are taught here. Whatever answer the app gives, the GPT-4 backbone, the GPT-4 model underlying enables the user to also get an explanation for those answers. Similarly, the user will also be able to interact with the different players or the different characters in this with the help of a role play feature, which is empowered by chat, which is powered by GPT-4. Coming to the next one. Wait a second. Yes. So the next one which I show here is Be My Eyes. So as you would guess by the name, it's a volunteer for blind people. So it uses GPT-4's image processing capabilities. GPT-4, as Scott would also have talked about in that perspective, is not just, as you also know, is not just a text processing engine. It also processes images. It looks at images, understands them, looks at the context. Even in this case, the context is quite important, and gives suggestions. So this is one of the major use cases of GPT-4, where GPT-3, for example, or 3.5 would not be helpful per se. Another important app which is quite popular is the Khan Academy, which is using GPT-4. And in this also, the objective is to customize learning to different users. And as Abhilasha was mentioning, there are cases where you would need to even fine-tune models. to bring them to such a level of quality where you could get a personalized education, or not necessarily personalized also always, but maybe education catered to a certain group of people, personalized to a group of people, if not a person. But then with models like GPT-4 and prompt engineering in the background, the actual power is anyway realized. So you need not really fine tune. GPT-4 or 3.5 cannot be fine tuned either. Next is Stripe, which is also using GPT-4. So GPT-4 in this application, in this payment related application, is helping on the one hand customers which are better able to understand the context of the business. They are able to ask different kinds of questions and get appropriate responses for them, ensuring a good customer experience. On the other side, it's also helping the business in detecting different kinds of frauds by analyzing, by doing data analytics on the inputs which they get on the app. We wanted to talk about LLM apps, not just GPT-3 or GPT-4 apps per se. So here I also present a section of apps from Cohere. So Cohere has been there for quite long. It has been there for almost 2 to 3 years, and it's a niche again. It's different from OpenAI, and it's certainly not that popular. But if you go to the Cohere's website, you will see that there are individual models dedicated to individual tasks like embeddings creation, toxicity detection, summarization, etc. Whereas in case of OpenAI, you don't have dedicated models for each of those tasks. Naturally, when you have dedicated models for something, right, which are kind of customized for that, you can expect their performance to be better. However, it's not as if you can't do it using OpenAI or using maybe within OpenAI using GPT-3 or GPT-4. It's just that when you use those models, you naturally have to do some effort in certain cases, as in make some investment of time in certain cases. So I won't be able to go through each one of them because it's a huge list. But then, for example, what you see here, the first one is a multilingual book. So this is meant to be an AI-powered search on the content of the book. So it's not something which you cannot do really using OpenAI with LangChain. But then, because in this particular case, when the app was being built, the maker of the app found even Cohere to be a good candidate for building. So they went ahead and built it. And so there are other apps also which have been built using Cohere. Interestingly, if you look at the different apps which are out there, while there are, as Scott was mentioning, there are language models which can't be used in commercial applications. That said, developers still use those models to make their own kinds of applications for use by themselves or in-house use. I would like to give here a short demo just to explain how these different kinds of models can be used in applications, and also just to kind of make you appreciate where and how you can make the choice. I will be using our enterprise conversational AI framework for that, which we call EKAI. EKAI is the short form for enterprise conversational AI. And what I want to show here is the trade-off which we have to make in terms of choosing different models. So as Scott was mentioning in the beginning, on one side you have the accuracy of the model, on the other side you have speed. They don't always map 1-to-1. They are not, so I wouldn't say they are inversely related, nor would I say they are directly proportionally related. But so you have to consider models. It also depends whether you're considering a proprietary model or an open source model. Then you have to consider whether the quality of the answers are good enough for your use case. It's not as, there are models which are higher in quality, better in quality, but it's not always the case as if every app you are designing needs that kind of quality. For example, if you are doing some kind of binary classification, which is very simplistic, I don't think you need to use GPT-4 for that, or for that matter, GPT 3.5 for that, or for that matter, GPT, for that matter, DaVinci for that. You could rather do it with Babbage or Curie, if your use case is of a certain kind. So here, let me start interacting with different models. So what I'm doing right now, the way I have coded up is, so I start with the name of the model. I ask it some question, I see the response, and let's talk through as it goes. So in our previous webinars, we have extensively demoed applications built with GPT 3.5, which is ChatGPT API, which is powering ChatGPT API. So we have demoed applications built using ChatGPT. Here, I would like to take a step back and talk about LLMs in general. So I'm trying to ask DaVinci 003, which is actually text DaVinci 003. about say quantum computing? This is a general question, you could ask about anything. I not just ask about quantum computing, I also ask about its applications. I just want to answer the question to be relatively more complicated. Now, so it's DaVinci 003, and I ask about these two things. So first of all, you see it's anyway taking some time to give the answer. Now, the fact is, if I were to use ChatGPT API for that, for people who have used ChatGPT API, they anyway know that it takes a long time to give you responses. So it's not as if it's not it's a downside for sure. But then, as OpenAI is anyway scaling the infrastructure, those things are meant to slow down. As in, the delays are meant to slow down. The app is expected to become faster. But let's leave that aside for the time being. So what I'm trying to say is you will encounter slowness in responses in some cases anyhow because of the demand of these models. Now, the answer which you get from here is the definition of quantum computing, and you have applications of quantum computing, and you have some 1, 2, 3, 4, 5, 6 points related to that, and these are broad points. Now, okay, so this is not a bad answer. In fact, it's a good answer. But let me ask the same question to DaVinci 002. And what's the difference between DaVinci 003 and 002? DaVinci 003 is based on RLHF, reinforcement learning through human feedback. So it has a human feedback component to it, whereas in case of DaVinci 002, you don't have. It's based on fine-tuned input. So let me do the same for DaVinci 002. See, the answer given by the model is relatively shorter, but then would you call it a wrong answer? It's not a wrong answer per se, it's just that the model is not as detailed as you would like it to be. However, if you were using this model if you were building an app for children, would you really need the kind of complexity, the kind of detailed grasp that DaVinci is going to provide? It's not required, right? In fact, in some cases, it is much more important that you use a model which provides a brief overview and in a very simplistic fashion. And that is what DaVinci 002 is giving to you. But even here, you realize that DaVinci took some time. Now let's ask the same question to Curie. This is the answer which we received from the model. One thing which I would like to point right away is that this answer is faster. So the speed is higher in this case. And again, while this answer may be isn't it qualitatively worse compared to the one given by DaVinci 003? It is an okayish answer for maybe consumption by children or maybe consumption by younger audience. So while models like GPT-4 or GPT 3.5 are indeed better, what I'm trying to say is it's not as if you require that kind of quality for every use case. And if, for example, if you were to ask this question to Ada, well, Ada's case will be hilarious because it's a complicated question for Ada, but let's look at its speed. So this was pretty fast. However, when you looked at the answer to the question, you realize it is not even answering the question properly. We asked about the applications of quantum computing, and it just talks about what is a quantum computer, what is a bit, and what is a qubit. And well, it talks about one kind of use of quantum computing, but it's a tangential answer. However, if you were to ask it something else, what's a computer, stuff like that, right? It would give you the answer which is accurate, because anyway, it's a very basic stuff. So this is one. What I'm trying to show here is you have models which give worse answers. However, those worse answers are returned faster. But when you just try to extrapolate it, so if you are using a model like ADA, or if you're using a model like Curie or Babbage, so I didn't show Babbage, but then Babbage is in between. Since these models can be fine-tuned, and when you fine-tune these models, you actually make them usable for your specific requirement. If you want to build a classifier using ADA, say for your system, or if you want to build a classifier using, well, for your use case, you want to build a classifier, you want to build maybe some kind of Q&A generator, again, based on your set of documents, where again, you don't want that depth of information. You could use these models. You could fine tune these models. So your fine tuned data is still cheaper than a DaVinci, but it would be way faster. So the speed is essentially a criterion here. And why is it a criterion? So in this case, it is fine if the response is returned slowly. However, if there were n number of processes which were dependent on this response, and you had n number of calls being made to these models, you can just assume that your application would even time out. So there is no question there. Now this was for OpenAI models. Now let me just go to some open source models. So I'll start with, let me just make a disclaimer. So because I've seen recently that as I make calls to OpenAI, these open source models, some of them are really taking a lot of time. So we may take some time to get the answers, but meanwhile, I'll give you a walkthrough the code. So in this case, I'm going to ask to start with, say, Stability AI. So as Scott was mentioning, Stability AI is one of the important contenders for usage in competition, for competition usage from the perspective of open source models, from the category of open source models. So I asked the same question to Stability AI, and let's see what's the answer it gives. Meanwhile, it generates the answer. I would like to give a walkthrough of the code as to how it could be used for even other models. And more important than how it could be used for other models, I want to just emphasize on even the different kinds of, well, frameworks which are there. And when I talk about frameworks, it's not necessarily in terms of LLM frameworks like LangChain and HisTech. It's also in terms of technologies which allow you to make more efficient use of these models via the infrastructure that they offer. So as you can see on my screen, so this is the code of Rasa, and here I have, of course, abstracted out the keys and so on. But if I start from the relevant section, which is line number 7, because prior to that you have code which is related to Rasa, I start with OpenAI and other code in line number 7. So in this case, I'm using LangChain and I'm importing large language models from LangChain. And here what I import is OpenAI, I import Cohere, I import AI21, I import, so AI21 is a provider of Jurassic models. I'll also try that shortly. I import Goose AI, I import Vertex AI. Now, what is quite good about Goose AI? Goose AI builds on top of OpenAI only, as in, so the answers it returns are using OpenAI models only. I mean, unless you really want to change that. However, it provides you the results at a cheaper rate. So in some cases at around 30% of the price. So it provides that infrastructure, which is utilized in such a way that your output, your cost is cheap. Your outputs are cheaper, as in they are produced at a lesser cost. Similarly, you have Vertex AI. Now, Vertex AI is on Google Cloud Platform. On Google Cloud Platform, certainly you are not using OpenAI, you are using Palm. So when you make use of if you want to make use of PALM model, pathways language model, and you really don't want to go into the depth of it in terms of, for example, writing Python code per se, right? You could have it on Vertex AI, and you could actually make use of Vertex AI in LangChain. So it's quite simple. So what you have is, for example, if you were to use Vertex AI or Goose AI, now let me again mention, these are not models per se. These are frameworks which give you some competitive advantage over other models, maybe in terms of pricing, maybe in terms of infrastructure, maybe in terms of speed. And of course, some of them are indeed models like Cohere. So what you need to do is you need to go to the, of course, respective providers. You need to get your API key from there. And then you just, these all are actually kind of embedded within LangChain. So there are integrations in LangChain which are already provided for these. So you could simply provide your open API, the respective API key, open API key, or Goose AI API key, so on for Cohere and so on for Claude. And you could just invoke your respective base model with the help of these classes. Now you could, of course, provide more parameters to these if you want to choose a particular kind of model, or if you want to choose a particular temperature, etc. But that side, that's the basic format in which you would invoke these models or systems is this. And here, as I was trying to mention, I have DaVinci 03, 02 invoked, and I also invoke Curie and Ada and Babbage. And what I've also tried to invoke is other open source models, which either come from Hugging Face. So the Flying T5 model, which is a very powerful model. So T5 has been there for quite long. I mean, people generally, when they talk about generative AI, they assume generative AI begins with GPT-3 or GPT. It's not that. I mean, you had BERT since long ago, for a long time. You had T5 for a long duration. So FLAN is an optimized or fine-tuned version of that. But then what I'm trying to indicate is generative AI is not restricted to GPT. That's what. So you have other models by Google and other providers. So here I'm trying to use FLAN model. I've invoked Stability AI model. I've invoked the Dolly model provided by Databricks. And then the very famous open source equivalent of GPT-3. And it's quite easy. So you provide your parameters, you provide the repo ID, along with other parameters, how much length you want, what's the temperature you want, etc. And then you simply make a call. Now, making the call, when you make the call, depending on what the kind of task you want to do, you define the respective template for it. For example, as Abhilasha was mentioning, so even if you have to answer a question, you don't answer the question directly. I mean, you can tell the model how it should answer the question. And in this case, I'm providing the template where I'm asking it to think step by step and then answer. So if you have a complicated question, it tries to answer bits by bits. So in some models, you'll see that happening. In all models, that doesn't happen, because in some models, the pre-trained base actually takes precedence over that prompt, and the results you get are from the pre-trained base. They are not so much customized just for your prompt, but when you see for open source models, in some cases, you will see the results are customized by the prompt you give. You provide the prompt template where you specify the instruction. Here it's Rasa, so I'm taking the input from the actions from the custom default fallback. And here, this is a simplistic code which I've just put to illustrate, to explicitly illustrate what is going on here. So whatever model I'm getting, so I'm passing instructions. Each instruction, each question which I'm passing is preceded by the model name. So in any other application, that could be a drop down. So it's a conversational app, so I decided just to keep it this way. But then I'm invoking the respective model, and more importantly, then whatever model is invoked goes to the LLM, is stored in LLM, and that is stored in the variable LLM chain. And then what the question which I ask is passed to this agent using LLM chain.run, and it generates the answer from there, and that answer comes on the front end. Now, let me see whether that Stability AI gave the answer or not. So Stability AI did give the answer. Now see, the answer given by Stability AI, which is not proprietary. I mean, you have it provided from the Hugging Face hub, right? So as I was showing in the code, this. So if you look at the answer is, I would say, reasonable. So it's not as detailed as DaVinci. It's comparable to Curie's response. It did take time, but then of course, these are models which are, in this case, I'm using Hugging Face. And if one were to, for example, ensure that the appropriate infrastructure, etc., gets provisioned from the other side, right? If you could scale up your account in that sense, right? Or as the usage of the models in that sense, then this would be faster. So, but what I'm trying to say is, this is a pre-trained model which is giving a decent response. Now, let me ask another question, and this time I'll ask a question to Dolly, which is by Databricks, and I'll let it generate its response, and then I'll go to some other stuff which I have to cover. Wait a minute. So I'm trying to do a comparative analysis, so it's natural that the same question will be asked. So as I'll come to that in a short while, but before that, I would like to give a very quick walkthrough of another very important concept which comes here. And this is also related to the choice of the language models which we have to do. And that is what is known as holistic evaluation of large language models, or in short, what is known as HELM. This will take a short while to load, but let me mention that the number of large language models has been increasing at a dramatic pace over the last many months now, and it's difficult to count those models. There were times like 6 months ago or 8 months ago when you could count the models on your fingers, at least the quote unquote popular models on your fingers. But right now it's not even that. So even if you were to ask how many models Google provides, right, you start counting. You have Palm, you have Lambda, you have Plan T5, you have T5, you have others similar. So if you look at, remember the slides which Scott was showing, that talks about the sheer number, and that was just indicative because the most important models were considered there. But then you have a huge number. Now it's not as if those models have uniform performance, so their performance has increased over time. And if you were really to choose which model is better, so of course, as of now, GPT-4 is the best model. Starting when you go to the next stage, you have GPT 3.5. Close on the heels is coming Claude, but again, Claude has been tested only by a small section of the users. So its responses are considered more natural, more intuitive, more driven by ethics. But then you don't have that comparison done extensively with other models. So a layman can't say that Claude is better. However, when it comes to all other models, or rather not all, but really a good number of models, popular models, right? There has been a framework which has been arrived at by a group of people from Stanford. So this is the HELM framework, Holistic Evaluation of Large Language Models, of language models. And they have considered different attributes there. And in an actual application, these attributes matter, right? So what they have considered is accuracy, calibration error, which is a marker of uncertainty in the model. The robustness, so you change the different kinds of input, you change the kind of inputs you're providing. You provide the same input in different ways, right? What's the quality of the response in that perspective? The fairness of the model, the bias in the model, the toxicity in the model. I'm not planning to go through each of these models and how they are performing in that in this webinar, but what I'm trying to indicate is that different models perform well in different aspects. For example, while you see, so let me also mention that this doesn't include GPT-4 and GPT 3.5 because this benchmark was made in early January and there was a paper which was published in early January, and GPT-4 anyway is post March. So you won't have it here. But this is kind of indicative of the other models, of the predecessor models. And I'm sure the group will be including GPT 3.5 and 4 as well. So they have already included GPT 3.5, though the results are not in this graph because that's not the way they have published in the paper. But 4 is there to be integrated. But what I'm trying to indicate is that when you look at accuracy, you have text-driven C002, which is at the best, which is the best performing one. when you look at a calibration error, you do get a calibration error maximum in case of text ADA 001. So that uncertainty feature, of course, I told you, right, that ADA gives childish answers. But then when it's not as if the other one on the extreme is DaVinci 003, or DaVinci 002, it's top. If you look at the robustness, DaVinci 002 performs better but close on the Hughes anthropic models, which are related to Claude. If you look at fairness, again, you have a similar kind of situation. But when you go into the deeper levels, right, when you look at the ordering changes. So in one case, Turing is Turing analogy is performing better. In another case, OPD is performing better. When you look at the bias, you find that open source models like GPDG, right, could be quite high at bias, and it also depends on what kind of data they were trained on. So and so on for toxicity. So one has to look at each of these parameters while judging whether a particular model is relevant for this scenario. So the Helm people who worked at this index, they consider different scenarios. There was a long list of scenarios, but these were 6 major scenarios which were considered. And again, without necessarily going to the detail of each one of them, but still trying to give you a feeling of the importance of these different kinds of evaluations. So even when you look at a basic question answering scenario, which is what generally chat is, right? So you ask something, it's a question, and you give it an answer. What these people found that certain models, for example, like Coheres, right, which is anyway not that popular, but it's a niche category of models, they have performed better, or at least marginally better than certain OpenAI models. So while in fact, in this case, you see that text DaVinci 002 is performing better than text DaVinci 003. Now, the fact is, the way these two models, 002 and 003, have been arrived at is different. There is no logic per se that 003 is always expected to be better in all benchmarks, right? So it's not as if 003 was not better in general. It's just that when you take the average, 002 has been found to be better. And I'll also come to what are the data sets on which they were evaluated. Similarly, when you look at robustness, fairness for question answering, the results which you get are different. So Curie's bias is comparable to Yalom's bias, but then and so on for text DaVincis. But if you were to look at it relatively from the consideration of or the perspective of certain documents, you would see a different picture. So if you were to, for example, do the same analysis for information retrieval, now information retrieval is on a set of documents. So here also you have to consider accuracy, robustness, and fairness. You get another index for that. And when you look at summarization capability, of course, in summarization capability, summarization metrics hold most importance, but it's also important that whatever summaries you are getting, right, it should not be a biased summary. It should not selectively consider or disconsider certain personalities or certain kinds of personalities or demographics, etc. So that analysis is done at this level as well. Similarly, you do that for sentiment analysis, and you do that for toxicity detection. So what is important here to consider that when this evaluation was done on different data sets, so what you have on the x-axis is different data sets, MMU, BoolQ, narrative Q, etc., etc. You find that it's not as if open source models or closed source models or those in between, right, limited models, right, restricted models, they are per se better. One category is per se better than the other category. I mean, there are cases where you find that they're quite comparable. If you look at the IMDb, right, the performance of these three models, classes of models, is quite comparable. So it's not as if when you're building your application, you can simply disconsider kind of data which you have. In fact, it's a bad choice. So if your kind of data is matching with a particular category, which these have, for example, have been referred with a particular category which matches with any of these categories as have been referred to here, then it's quite important to consider the accuracy for a certain kind of model. So similarly, when you look at cumulative accuracy, this accuracy, this was actually at the cluster level, as in at the category level of open source limited models and closed source models. But when you consider at a level of individual models, you again see that the accuracy is different for different data sets. So what I was trying to emphasize is, and this is let me also mention, this is a very well established benchmark. So so I've tried to indicate the extensiveness of that by just also referring explicitly to the paper which was produced for this as a result of the evaluation which was done here. And this holistic evaluation has considered all models. Well, when I say all, I do mean the prominent still, but then what the all in the sentence is meant to indicate models from different categories: open source, closed source, proprietary. As an even within closed source, they just don't limit to OpenAI, they go to Cohere, right? They look at Anthropic's models, and they have given extensive evaluation. So what I tried to show was only the best performance on the parameters. But if in case you were interested on each of these metrics, right? In case, for example, you wanted to look at the accuracy on a certain kind of data set. So even though I say DaVinci 003 is most accurate, but then there are cases where you find that 002 is more accurate, as in fact, in the averaging scenario, right? For the case which I considered, 002 was found to be better. It was for a question answering scenario. This is not a question answering scenario per se. So this metrics shows that certain models are better performing in certain scenarios. Similarly, if you look at robustness or maybe the other scenarios which they have considered. So on one side, they have the core scenarios which they have tested for all models, but then there are some special targeted scenarios which they have tested for a specific set of models. You need to consider what kind of data source you have, what kind of requirement you have. You need to just check which are the best models performing as per this benchmark, because it is a neutral benchmark. Of course, if you go to OpenAI's website, it will show you results favorable to GPT-4 or GPT-3. Similarly, if you were to go on Anthropics, it would show you favorable results. So there is no unbiased opinion there. However, if you were to look at this metrics, you will get unbiased opinion. And while if you want to build something very quickly, if you want to do a prototyping, right? If you want to do a prototype, just go for GPT-4, check it out whether it's even capable to be being built. But that said, once you have settled down for that, once you really want to build it and you want to explore different cases, options which are faster or maybe cheaper, etc., and which are still more accurate, right? It's important that you consider this metric. So let me just see whether okay, so I got answer from Dolly as well, hopefully much sooner, but this is what I see here. So you see, even Dolly's response is good enough, right? So it does add unrelated information. For example, it talks about when was the first quantum computer built, and this answer is not expected to be given by GPT-3 or GPT-4 because it doesn't provide unnecessary information. But then that said, the response which you are getting here is still relevant to your question. So as a part of the response is relevant to your question. So this is what I had from the perspective of applications of large language models, the different ways in which you can rather use different kinds of models. So here we did discuss LangChain. I discussed LangChain centric incorporation of these integration of these models. But what I also tried to emphasize was that when you talk about integration of these models, it's not as if you just need to consider the models per se. These frameworks also allow you to incorporate different, I would say, solutions which provide you other enhancements over your model. So you have, for example, deep infra, which provides you a separate, different kind of infrastructure. You have Goose AI, which provides you cheaper models, even though you still end up using OpenAI models. So cheaper price, even though you still end up using OpenAI models. And then I also try to indicate that when you have a use case which you want to implement using LLMs, it's best that you go by the benchmark, which is kind of neutral. And it so turns out that there are models which are less toxic, which are more robust, which are less biased, which are more fair, and for a certain kind of data set, and you should use those models. So thanks for the patient listening, and now we'll be happy to answer any questions.
Thank you, Shubham. We do have a few, and I suppose those must be visible to you, but I'll just read them out. We have a few from Hitesh Goyal. How will you handle the situation where different prompts are required depending on the data that comes out from vector? How typically is this handled?
How will you handle the situation where different, I'm just reading through it. Different prompts are required depending on data comes out from the vector. How typically that is handled? All right, see. Okay, so maybe I'm just trying to confirm my understanding here, but if it is not that, please type it out. So your point is that maybe you have a document processing use case, and you know that your model will give out different kinds of answers, and you need to selectively provide different inputs based on the kind of answers. Now, as we have done in our use cases, we know a priori what is the variety of answers you can get. Of course, it doesn't mean that we know each and every possible answer that comes out, but we can broadly categorize the response into different classes. And for each class, we can indeed build a kind of classifier where we invoke that and then ask the model to behave in a certain way. For example, if you are fetching answers from, say, a website which is scraped out, and well, you have, say, 100 pages there, and you asked a question. Now, in some pages, you will not have answers only in text format. You will also have tags, etc. if they were not extracted properly, or even if they were extracted properly, you will have numbers, etc. Now you have numeric data which is coming from a page, and you don't want to handle it just like that, right? I mean, you want to remove that data, or you want to handle it in a specific format, but you know that you are going to have this kind of data, right? So even when you will receive the prompt from you will receive the response from your large language model, you know that it can belong to certain categories, and you will add a subsequent condition there that if a response is of a certain kind, then you do so and so. So what I'm trying to indicate is, even though the responses will be of different kind, but still they should fall in some class, and you could use a LLM based classifier for that. So LLM based classifiers are generally more optimal because these are complex tasks, and you could then have customized logic on top of it. So next is any point of view on layout aware PDF parsing. Well, see, we have different applications where we have done that. For example, I think you were there in the last webinar as well. So where we showed parsing of medical documents which were in PDF, and the answers which came, they were quite good. We also have a resume parsing application which processes PDF files. Now the thing is, if you look at, for example, GPT 3.5 models, this is not meant to be layout sensitive in the sense that it will automatically consider that certain section is belonging from a certain block of text. So it depends on your extractor. So let me mention that these models are, if you ignore GPT-4 reads your images, but your images, it's different to read images, but it's reading images is not in the same sense as reading a PDF document, right? What I'm trying to say is, when you pass your document to any of these models, you first ingest the document through some kind of loader, and that kind of loader is agnostic of the kind of LLM you are using for parsing. Now, if you look at LangChain, the loaders which are publicized on Llama Index's page, for example, I have seen that they are quite robust loaders. When you use those loaders, the text which you get is anyway layout sensitive, right? So what I'm trying to say is that layout sensitivity comes from the robust loaders you use, not from the language models per se. Next is, are there known ways to quantify accuracy of the deployed bespoke LLMs? And also, how do you manipulate training cycles if we can to correct toxic and inappropriate responses? Well, we did discuss one of the most important ways of quantifying accuracy, which is Helm, and you can look into more details of the evaluation there. But how do you manipulate training cycles if we can to correct toxic and inappropriate responses? Unfortunately, what we have seen, right now the state of LLMs or this generative AI field is such where you don't know a priori how many training cycles will lead to a certain kind of output. So there is a manual intervention required in most cases. Even if you were to set some kind of a benchmark which you would like to use for automating the results, you would still have to manually review it because of the kind of confidence there is in LLMs right now. So, I mean, just consider the fact that certain LLMs have known to be toxic, right? And when the LLMs are anyway known to be toxic, the very analysis of toxicity of the data produced by those LLMs, the criterion which you're using for analyzing the toxicity, right? Even you need to consider that with a pinch of salt. So what I'm saying is, when you do this toxicity analysis, first of all, it's difficult to fully automate the process, and you need to do it repeatedly, and the number of training cycles per se, it varies. So if you, for example, let's talk about fine-tuning of a model, right? So you have a simple task where you have a pre-trained model and you want to make it learn a particular lingo or maybe brand voice of a particular brand and voice of a particular brand, and then you fine tune the model. How many iterations do you require for that? Well, it depends on the amount of data you are passing to the model. It depends on the kind of accuracy you want. It depends on the kind of so when I say the kind of data, it of course means the quantity of data for sure. So I mean, whether you are passing it, say, a book of information or say 10 pages of a website, but it also depends on the domain specific nature of the data, right? Whether your data even has terms which are falling in a different domain altogether, right? For example, in most businesses, a certain term will not mean what it means in real life, or maybe what it means to people speaking of it casually. So unfortunately, even as we have looked at it in greater detail, we have seen that whenever it comes to fine tuning, whenever it comes to iteration, unlike in conventional machine learning, where you have very calibrated metrics which you could use as thresholds to cut off the iteration process, in case of large language models, at least as of now, you don't need that thing doesn't work. So it's more likely to lead to wrong answers. So if it is about manipulating training cycle in terms of how do you make it more accurate, more less toxic, more appropriate responses, that that option, there are prompts which you can design where you explicitly ask the model to constantly check for higher levels of subtle levels of toxicity. For example, it's funny to say, I mean, but anyway, it's worth it. So if you have a paragraph and you want to understand the toxicity, you could just ask the model to rank the paragraph on toxicity on a scale of 0 to 10, and it will give you a rank to it. But now, suppose your toxicity is reduced, you again ask it to give a rank. It gives you there will be a time when it is not going to change its rank. Maybe it is ranking it at 2 out of 10, right? But then you still want to rank it lower. Now you won't ask it to just analyze on toxicity, right? You would ask it for subtle attributes. Maybe you'll ask it for inclusivity and toxicity. So there are people who, for example, will consider using gender specific language also as toxic, right? So what I'm trying to say is you will add more layers to toxicity to actually make the model still identify certain elements as toxic. Sure, so we'll send the slides, definitely.
Yeah, so we will be sharing the recording of this webinar along with a link to these slides with everyone who has registered and attended this session. So yes, that will definitely happen. And it's been a long session, and I hope we have answered all your questions and doubts. So thank you everyone once again for joining us today. And I hope we continue this association going forward. Thank you everyone.
Thanks, everyone.
Thank you.